Welcome to Stellar Revelations. If you're a fan of all things cosmic, you're in the right place. Today we're diving into the explosive world of supernovae, the spectacular explosions of dying stars. These celestial phenomena are not just visually captivating, but they hold the key to unraveling some of the most intriguing mysteries of the universe. From the life cycle of stars, the creation of elements, to the mysterious dark energy, supernovae have played a pivotal role in our understanding of the cosmos. So buckle up as we embark on a journey through time and space to uncover the secrets that supernovae have to offer. Let's get started. Have you ever wondered how the universe is expanding? This question has puzzled scientists for centuries, leading them to probe the outer reaches of space in a quest for answers. In this cosmic odyssey, one celestial phenomenon has been instrumental in illuminating our understanding. Supernovae, the spectacular explosions of dying stars, are not just visually captivating, but they hold the key to unraveling the mysteries of our ever-expanding universe. When a star much larger than our sun exhausts its nuclear fuel, it collapses under its own gravity and then spectacularly explodes. This explosion is what we call a supernova. These celestial fireworks are more than just awe-inspiring spectacles. They are cosmic beacons that have helped us map the universe. By observing the light from supernovae, astronomers can measure the rate at which the universe is expanding. This is because the brightness of a supernova tells us how far away it is. The farther a supernova, the fainter it appears. By comparing the apparent brightness of a supernova with its actual brightness, astronomers can calculate its distance from us. This is where supernovae serve as cosmic distance markers. They have been instrumental in revealing that the universe isn't just expanding, but this expansion is accelerating. This groundbreaking discovery, made possible by supernovae, has led to a profound shift in our understanding of the cosmos. Supernovae are also the universe's primary source of heavy elements. The explosion disperses these elements across the cosmos, seeding future generations of stars and planets. In fact, the very atoms in our bodies were once part of a supernova explosion. So, in essence, supernovae connect us to the cosmos in a very fundamental way. They're not just distant, intangible events. They're part of our cosmic heritage. In their violent death, supernovae have given birth to our understanding of the universe. They have taught us about the life cycles of stars, the creation of heavy elements, the mechanisms of stellar explosions, and their use as cosmic distance markers. As we continue to explore the cosmos, these stellar explosions will undoubtedly continue to shed light on our universe's most profound mysteries. Supernovae, in their violent death, have given birth to our understanding of the universe. Did you know that stars, like humans, have a life cycle? In the grand cosmic ballet, stars are born, live, and die. The birth of a star begins in a nebula, a vast cloud of gas and dust. Over millions of years, gravity pulls this gas and dust together, forming a protostar. This is the first stage of a star's life. The protostar gradually increases in size as it continues to attract more matter from its surroundings. Eventually, the core of the protostar becomes so hot and dense that nuclear fusion begins. This is the moment a protostar becomes a main sequence star, the stage where our sun currently resides. For billions of years, the star will shine bright, converting hydrogen into helium in its core. But what happens when the star exhausts its hydrogen fuel? The next stages of a star's life are determined by its mass. A star like our sun will swell into a red giant, its outer layers expanding while its core contracts. Over time, the core will heat up enough to burn helium into heavier elements like carbon and oxygen. The final act of a star's life is its most dramatic. If the star is massive enough, it will explode in a supernova. This explosion is so powerful that it can outshine an entire galaxy. In this violent event, elements heavier than iron are created and scattered into space. What remains of the star after the supernova depends on its original mass. A star like our sun will leave behind a white dwarf, a dense object about the size of Earth. If the star was more massive, it might become a neutron star, an incredibly dense object with a diameter of only about 20 kilometers. The most massive stars can collapse into a black hole, a point in space where gravity is so strong that nothing, not even light, can escape. The death of a star in a supernova is not an end, but a transformation. Indeed, the life cycle of a star is a testament to the ever-changing nature of the universe. Ever wondered where all the elements in the universe come from? Our universe is a rich tapestry woven with a multitude of elements. But have you ever stopped to think about their origin? The answer lies in the spectacular celestial phenomena known as supernovae. Supernovae are the grand finale of a star's life cycle, a spectacular explosion that releases a tremendous amount of energy, but there's more to this cosmic spectacle than meets the eye. Supernovae play a crucial role in the creation of many of the elements we find in our universe. Now let's delve into the process of nuclear fusion. It's the heart of a star, where lighter atomic nuclei combine to form heavier ones. This process starts with the fusion of hydrogen to form helium. As the star ages and the hydrogen supply dwindles, fusion continues with heavier elements. Helium atoms fuse to create beryllium, which then fuses with more helium to create carbon, and so on. This process continues, creating elements up to iron. But what about elements heavier than iron, like gold or uranium? These can't be created through fusion in a star's core because that would consume energy rather than release it. Here's where supernovae come into the picture. The intense pressures and temperatures during a supernova explosion are enough to force these heavier elements into existence. So, the gold in your jewelry, the calcium in your bones, the oxygen you breathe, they're all products of the stars. These elements are scattered across the universe when a star explodes, eventually forming new stars, planets, and even life. This understanding of element formation underscores the interconnectivity of everything in the universe. We are not separate from the cosmos, we are an integral part of it. The atoms that make up our bodies were once part of a star that exploded, scattering its enriched guts across the cosmos. We are made of stardust, forged in the heart of supernovae. What could be more powerful than a nuclear bomb, you may wonder? Well, the universe has an answer: stellar explosions. When a star has exhausted its nuclear fuel, it collapses under its own gravity, triggering a supernova. This isn't just any explosion, it's an event of cosmic proportions. In fact, a single supernova can unleash more energy in a moment than our sun will produce over its entire 10 billion year lifetime. It's a spectacle that can outshine an entire galaxy, making millions of stars seem insignificant in comparison. This massive release of energy is what drives the creation of new elements, sending them hurtling across the universe, seeding future stars and planets. The power of these stellar explosions is simply staggering. They are the universe's grandest fireworks, illuminating the cosmos with their brilliant displays. Yet, as awe-inspiring as they are, they also serve as a stark reminder of the immense forces at work in our universe. In their death throes, stars unleash a power that defies comprehension. What happens after a supernova explosion? This is one of the most intriguing questions in the field of astrophysics. After the colossal stellar explosion, the remnants of the supernova paint a fascinating picture of the star's life and death. When a star goes supernova, it doesn't simply vanish. Instead, it leaves behind a cosmic spectacle of gaseous remnants, glowing brightly with the energies of the deceased star. These supernova remnants can linger for tens of thousands of years, providing a treasure trove of information for scientists to decipher. They allow us to understand the mechanisms of the explosion and the elements that were present in the star before it met its explosive end. Now let's delve a bit deeper into the heart of these remnants. If the original star was massive enough, the core collapses under gravity during the supernova, forming a neutron star. These are some of the most extreme objects in the universe, squeezing more than a sun's worth of material into a city-sized sphere. Neutron stars are so dense that a teaspoonful of their matter would weigh as much as a mountain on Earth. But the story doesn't end there. For the most massive stars, even a neutron star can't withstand the force of gravity. The core collapses further, creating a gravitational pit so deep that not even light can escape. This is the birth of a black hole, one of the most enigmatic entities in the cosmos. These black holes can continue to grow, devouring nearby matter and shaping the galaxies they reside in. In essence, the supernova remnants are not just the final echoes of a star's life, but also the seeds of new cosmic phenomena. They are the birthplaces of neutron stars and black holes, and the factories of heavy elements that enrich the universe and form the building blocks of new stars and planets. Even in death, stars leave behind a legacy that continues to shape the cosmos. Are supernovae linked to the mysterious dark energy? This question has been at the forefront of cosmological research for decades now. You see, supernovae are not only the universe's most spectacular fireworks, but also its most enlightening teachers, offering us unprecedented insights into the elusive dark energy. Scientists have been studying Type Ia supernovae, which are thermonuclear explosions of white dwarf stars. These stellar phenomena have a remarkably consistent brightness, making them perfect standard candles for measuring cosmic distances. And it is this precise measurement that has led to a groundbreaking revelation. In the late 90s, two independent teams of astronomers were observing Type Ia supernovae to determine the rate at which the universe is slowing down. However, what they discovered was not a slowing down, but an acceleration. The universe, it turns out, is expanding at an increasingly faster rate. This shocking discovery turned our understanding of the universe on its head and introduced us to the concept of dark energy. Dark energy, a term coined to describe the unknown force driving this acceleration, makes up about 70% of the universe. Yet despite its dominance, it remains one of the most enigmatic entities in cosmology. So, how does this tie back to supernovae? Well, the key lies in their brightness. By measuring how bright these supernovae appear from Earth, compared to how bright they actually are, scientists can estimate how much the universe has stretched since the light from the supernova was emitted. This has allowed us to trace the expansion history of the universe and infer the presence of dark energy. In essence, the study of supernovae has become integral to our understanding of dark energy. It's a testament to the fact that sometimes it's the most violent and explosive events in the universe that can shed light on its most subtle and elusive phenomena. Supernovae have shed light on the darkest mysteries of the universe. So what have we learned from studying supernovae? Supernovae, these dramatic stellar performances, have served as a veritable treasure trove of knowledge, shedding light on some of the most profound mysteries of the universe. Let's delve into the key insights we've gained. Firstly, supernovae have given us a front-row seat to the life cycle of stars. From the initial stages of a star's formation to the dramatic end in a supernova explosion, we've been able to piece together the cosmic journey of these celestial bodies. It's through observing these grand finales that we've come to understand more about the birth, life, and death of stars. Secondly, supernovae have played a pivotal role in our understanding of the universe's expansion. It was the observation of distant supernovae that led to the discovery that the universe is not just expanding, but doing so at an accelerating rate. This revelation has fundamentally altered our understanding of the cosmos and paved the way for the concept of dark energy. Next, supernovae have provided illuminating insights into the creation of elements. Through these cosmic explosions, we've discovered that the heavy elements we find on Earth, such as gold and uranium, are not born in the peaceful heart of a star, but in the violent throes of a supernova. This has given us a deeper understanding of the chemistry of the universe and our own place within it. Finally, the sheer power of stellar explosions demonstrated by supernovae has left us in awe. These cosmic fireworks release more energy in a single moment than our sun will produce over its entire lifetime. This staggering display of power has deepened our understanding of the forces at play in the universe. In the grand spectacle of the cosmos, supernovae have proven to be some of the most illuminating performers. Their study has not only expanded our knowledge of the universe, but also highlighted just how much there is still to learn in this vast cosmic dance.